Hi everyone, this is Nilson Lima, and we're here today for this tutorial. It means we are going to create a volumetric fog using the particle systems, and it will be interactive. So, first things, we are running Unreal Engine Editor 4.21, and we have an empty scene here. I have just one post-process volume with exposure, contorted in 1 and 1 in min and max brightness, and infinite extent. You have your dynamic lights and nothing else. Scarce field blueprint is set with cloud opacity 0, so you don't see any clouds here, we don't want. And I removed the walls and the floor. I created this big one because I want to spawn some particles here. And that's it. Let's go. I created a folder here, and I have prepared for in Photoshop this texture here, so we can have some dramatic effects going on. And another thing that I want to show to you guys is how you activate volumetric fog in Unreal Engine is grabbing exponential height fog here in visual effects, placing height here. Once you put the exponential height fog, you have to come down here and find the section volumetric fog, and you check this one here. Check that when I click in the eye here, you can see the effect of volumetric fog is given to the scene. See it like something bluish here? It is our fog. We can increase a little bit more the scattering here. I can like place 1 into the density, 0.5 and fall off. Now if I look to the sun, as I come to the distance, let's put here some for okay. This is how it goes, and with 0.5 in density you can leave the scattering just like the default value. And I'll pick some light here. Let's pick this point light. You see that there is some scattering happening from the origin. Let's increase the intensity here to 20. Let's make this movable so you don't have to rebuild lights and anything else. So this is how our point light reacts right here. So if you give this point light a different color, the scattering will adopt the light color. So it's like you have the fog receiving the color from the light. And the basics of volumetric fog is just what I have shown to you guys. Even if we don't have a bigger value here, we almost can't see the volumetric effect around the light here, but individually we can increase down here. So I can like use 10, so I can increase how the fog affects this, only this light. And for volumetric fog, this is just what we have. Now what we're going to do today is picking some particles and create the fog ourselves and give them some effects that is quite cool. Our goal is to emulate a swamp fog, and for that, just starting creating a material that we call volumetric fog. And for this material we need to change the material domain to volume and the blend mode to additive. Right now, for particles you have quite simple way to create this material. You have to add a sphere mask, and for a you should just place the warp position, and as we are going to make particles, so you need to know your particle position against warp position. And we could give a scalar for radius, but we want to control this while in the particle systems, so again use here particle radius. So all these inputs here came from directly from our particle systems. And we can have a scalar fit to harness. Let's call this harness, and we plug this to extinction. For albedo we can create a parameter and call it color. Let's give it a bluish color, sort of, not much. We can tweak this later. Basically this is everything you need to have a very basic particle systems going on. So now we have material. Now you create an instance, so you can use this and tweak the values later. You can leave this as it is, and then you're going here to particles, and let's create a particle systems. We call it P interactive. Let's first make a volumetric fog, so I can create two of them. Let's open this. And right now required we have to set this material we have created, the instance one, and sort mode, distance to fill, all that we need right now. And for the sake of our volumetric fog particle system, we just need these defaults we just have here. You just create some extra data you want to spawn like 1000. The burst method interpolated. Everything else is okay. Lifetime, just want some randomness. So lifetime you just make a minimum 1 and maximum 2. Initial size, you want this like, we will change this later, don't worry. Velocity, just want some velocity on the Z, nothing else. Yeah, don't mess with color overlays for the moment. And just for the sake of us looking at this was changed because since I have used it for a particle system, some attributes have changed, so I have to save these materials again. So you'll have them open for us up here. And just near our pawn here, we will place our, see that right now these incredible shapes you're seeing is because the time from 1 to 2 that the particles last. Okay, so our basic shape, because all the particles are sphere masks, you generate this shape for us. So you have to deal with the shape, and for that we have to place here and for location a cylinder, and I can like use this 500. One. So this is what it looks like now. So we have a cylinder, and if we see this value of 300, just place in 1000. It is dealing with the height. So don't want this to be too big, so you can have this like 200 and it'll be fine for our purposes. So make sure it is like near the ground, and at the cylinder 500 is the diameter, so 1000 will be this big. See that we're starting to lack particles to fill the space, so you have to increase if you need to. We'll keep this to 500 for now. And I am not liking this bluish color, so I can come here to the material and make it even lighter, almost white. You see that we still have our feet not covered, so we need to change the Z a little bit more. That's nice, almost in height to the top of the hips. And see that right now it's just a ugly fog happening. There is no interactivity. It is then just being popped up there. But this is already something. You can control at the places you want your volumetric fog to be present in our scene, so you can have less impact on performance. And for this, we will delete this instance. Right now, all we have for volumetric fog is done. It could add something to the material to give a different noise. So basically you can like put a texture sample, and you can use our texture right here, and this noise you are generating, you have to multiply it for your extinction. You might not be happy on how the things goes here, so maybe you can even multiply this for another scalar. You call this extinction. Oops, sorry for that. And for now, let's leave it at 1. I can have the same for color, but right now we don't need this. And see that our fog just got interesting. We have some added shapes, so it's more cloudy. We can even get it a bit up. It's still hitting our hips, which is nice. Just make sure your feet is still there. And that's it, guys. Right now we are done with our particle systems, and now we'll create a variation for this. So we'll duplicate this. Let's rename it to interactive volumetric fog, and we'll need this instance to be controlled on some parameters, and you create a blueprint for this. It will be an actor blueprint. That's called BP interactive volumetric fog, and you add a particle system to this here, and you just say you can use this as a parameter, but you don't need it. You just check here, and the template, you make it be your particle systems. You save this, and you're good to go. So you can delete this old one. You can place our blueprint here. It will be exactly the same. And let's open the new copy we have. And so, for us to have some interaction with the volumetric fog, two things we need to understand. This particle systems runs on GPU. It means the GPU can make decisions on collision on its side for data that is passed to it from the game. It won't happen to the opposite. So the particle systems running on GPU can send info back to the game. So it won't work. And so how works collision with the particle systems? You network edit and tell what will happen with your particles. See, you see the effect on the particle sides. You can see it on. You don't want mean and maximum collisions here. You want the particle to be killed and this to be dynamic. Physical applied, you just want to interact with whatever actor is going there. So like checking for a sphere collision into the scene, and it is to apply physics into the particle. So send data from the game, from the CPU side of things to the GPU side of things. And for the mass, you can give some more mass to the particle. Later you give you don't want to drop a detail, you want the maximum detail on your fog. You can leave this as well. You can increase this to 10,000. Don't want to limit where you have this. We could, but it's not the case. So now we have telling what will happen to the particle, but we still don't have much effects going on. What else happens with the particles when we are moving through them, besides the effect to kill them? It is been told here in the actor collision. We need also a thing, let's see, attraction, point attractor. This point attractor, at the position, we want this to be a parameter. Because parameter, nothing else besides attractor. And you give a range from the position of the particle. You can start with minus, so it's a quite wide area. We have two of them. So this is the whole distance the attractor is happening. The parent modes here need to be direct. A range for this is how far from the point we want this to happen. So we can start with a value of 200, and for the strength, positive value here will mean all the particles will move towards the point of collision, and what you want is when you have an actor walking through the fog, for it to be repelled. So for the repulsion, we need to place here a negative value. Okay, this will be tweaked later. And you want the strength to change based on the distance from the collision has happened. You want to affect the base velocity for it, override it sometimes, use the third space position for this, and this is the axis that you want the particle to be affected. We might not want the negative z because this is below the ground, so you can like uncheck this, and we are almost ready for this. You can save. We can get back to our blueprint here. We already have our correct particle system set here, and what you need to do is to feed this parameter here. So what will cause the collision? It will be our third person character. So this third person character, you have to edit its blueprint, and you need two things. You need to tell two collision points and you choose to be the legs around this area, because we are, remember, the fog is going right here near the hips, so we need to place here some collision following the leg or the foot, aligned to the foot maybe. So right here in the mesh, you add a component and you look for collision. So collision right here, could be a sphere, could be a capsule. Let's make it capsule because it's easier to align it to the leg. You can like look over the top, align it to the foot position. Let's call this right leg. Let's duplicate this one and call it left leg. About the ankles. So now we need to go back to the perspective mode and see how it's doing the height. So we don't need this moving below the feet. You can have it a little bit higher. The same for the right one. Make sure they are attach it to the mesh. Otherwise they will not follow the transformations on the position for the mesh. So you make sure this, and you have to check if the capsule you get near the hips. So maybe we can increase this a little bit, 1.2. Maybe you can stay this as 1. Sounds to do the trick. Just confirm how is this into the feet. Make sure to align it the most properly. And since I have changed only the Z, the other one will copy the location as well, 50. So here has to be 50, 1.2. Compile, save. Now that we have the collision set, you have to decide how you do the check-ins right now. So you choose to do this at the tick event, and you just drag both of them here, and what you want this is its road position. So you give us the road position. And how do you know what to do? You can like get all actors of class BP, interactive fog down, and get the first one. And we need to get the particle and you need to select the vector parameter, and we'll use this value here, and the parameter name, it has to be the same name, the same case used in the particle systems. And you have to duplicate this one, and this other one here. So we have everything set now. So we can like stay here simulating. So we are assuring that our tick event is being handled. See that as I am inside the area with the fog now, we have some disturbance happening. If I'm not there, just a sec. I want to remove it in. So this is like undisturbed fog. You can see by the border coming, and if I approach, there is already some disturbance happening. And remember, our disturbance happens in the z-axis positively. So right now, when we are playing, you are affecting the fog. How do I know? Let's bring some light. How this interference will get better to see will be determined by the color you give to your fog and this mask here, so you can increase the details. Since this one is quite simple, you could have something panning, an animated texture in a render target made by another material. You decide. You don't want to have this material too much complex, or the performance will be penalized. And to make sure you have a clean way of interfering with your fog, in the point attractor you have to deal with these values here. So we increase the range and diminish the strength for the reversion. We could also in the actor collision we can change the particle mass like by half. Let's pick this. We don't want this light too strong. Let's place our hardness. It'll change as well. See that the disturbance is happening quite a lot here. So it is too strong. Happen in a big area. Have to do this until you find the perfect combination of and that's it. The other points that you want to is like using this strength and have a even smaller values like 120, 200, minus 200 if you are running, and as higher value like minus 100 if you are walking, something like that. So you can suppose this a parameter as well that you can change here to, and call this as it is, strength. Remember just to be a DPM direct, this is important.